Hey everyone, and welcome! Today we're going to dive into a skill that really separates the pros from the beginners, handling errors in Python. We're going to see how you can take a script that breaks at the slightest problem and turn it into a truly robust application that just keeps on running. Let's do this. So picture this. You've spent hours crafting the perfect script. The logic? Flawless. The syntax? Chef's kiss. But then, the real world gets involved. A user types something weird, or a network connection drops, and suddenly, chaos. This is the exact problem we're solving today. What happens when our clean, perfect code runs into the messy, unpredictable real world? And this is what that chaos looks like. On the left, we've got our happy path. The right answer, everything's great. But on the right, that's what happens when things go wrong. You get this huge, scary wall of red text called a traceback. And the most important part? It means your program has just stopped. Dead. Today, we're going to make sure that never happens again. All right, so let's actually break down what's going on here. It turns out not all errors are the same. And you know what? Understanding the different kinds of crashes is the first step to making your code invincible. So broadly speaking, there are three types. You've got your compile time errors. These are basically just typos, like a forgotten colon. Your code won't even start. Then you have logical errors, which are sneaky. The code runs just fine, but it gives you the wrong answer. You know, like 2 plus 3 equals 4. But what we're focused on today is that third category, runtime errors. These are the ones that pop up while your program is running, usually because of some bad input, and they bring the whole show to a screeching halt. And this right here, this is the whole ballgame. When a runtime error hits, your program just stops. That's it. Now imagine a web server or a big data processing script. You can't just have it shut down because one little thing went wrong. Your code has to be tough enough to handle these little hiccups and just keep right on chugging. So how do we actually stop our programs from crashing? Well, Python gives us this incredibly powerful and honestly pretty simple tool to do just that. This is our first line of defense, the try except block. The logic here is super intuitive. It's like you're telling Python, hey, I'm about to do something a little risky, so please try to run this code for me. And then you give it a backup plan. But hey, if something goes wrong, don't panic, just jump over to this except block and do this instead. It's literally a safety net for your code. And just look at the difference it makes. The code on the left, it hits that division by 0, crashes hard, and it never, ever gets to print by. But the code on the right, with that simple try except block, it tries the division, sees the error, jumps to the except block, prints error, and this is the magic part. It keeps going and prints by. We've handled the problem without killing the whole program. And this is a double win, right? First, obviously, our app doesn't crash. That's huge. But second, instead of blasting the user with that scary red text, we can give them a nice, clean, friendly message. This makes your programs feel so much more professional and user-friendly. It's about handling errors with grace. Now, a super important thing to remember is that the except block is purely a backup plan. It's like a fire extinguisher. If there's no fire, if your try block runs perfectly fine, and say you're dividing 10 by 2, then Python just skips right over the except block. It only ever runs when it's actually needed. Okay, so we know how to catch errors. That's a massive step. But we can do better. We can get way more precise. You see, catching just any old error is good, but being able to catch the specific error, well, that's a game changer. I mean, think about it. Your code can break in a ton of different ways. Let's say you ask a user for a number. They might type in 0, which would cause a 0 division error. Or they might just type the word cat, which would cause a totally different problem, a value error. Just printing a generic error message isn't super helpful, is it? We need to get specific. And lucky for us, Python has a whole toolbox of specific exceptions for specific problems. There are names for all these common issues: 0 division error, value error, file not found error, and a whole lot more. Using these lets us create a tailored response for exactly what went wrong. Here's my favorite analogy for this. Think about going to the doctor. If you have a skin rash, you don't go to the dentist, right? You go to a dermatologist, the specialist for that exact problem. Well, exception handling is exactly the same idea. So in our code, writing except value error, that's our specialist. It only handles that one specific problem. On the other hand, writing a broad except exception, that's like a general doctor. Sure, it'll catch almost anything, and that might sound good, but it can be really dangerous because it might hide bugs that you had no idea were even there. And the way we use these specialists is super simple. We just stack them up. You can have multiple except blocks, one after another. Python will check them from top to bottom, looking for the first one that matches the error. This gives you incredibly fine-grained control over how your program reacts to different problems. All right, we're almost there. We know how to try risky code, and we know how to catch specific problems. But there is one last crucial piece to this puzzle. It's all about the things that absolutely positively must happen. You know, like always closing the fridge door. Exactly. Think about opening a file on your computer or connecting to a database. These are resources that need to be cleaned up properly. You have to close them when you're done. But what if an error happens after you've opened the file, but before you've closed it? Your code jumps to the except block, and that close file command might get skipped entirely. Leaving resources hanging open like that is a recipe for disaster. And for this, Python gives us the finally block. Think of this as an ironclad guarantee from Python. Any code you put inside a finally block will run, no matter what. It runs if everything succeeds, and it still runs if something fails. It's the last word every single time. Let's just trace the flow here to see it in action. On a good day, with no errors, the try block runs, the except block is skipped, and then the finally block runs. Now, on a bad day, when an error hits, the try block stops, the except block runs, and then the finally block still runs. See? It's the one constant. That's why it's perfect for all your essential cleanup tasks. Okay, let's bring it all home. We now have a complete toolkit for writing Python code that isn't just getting the job done, but is genuinely resilient, professional, and pretty much unbreakable. So let's recap the big ideas. 1. Always wrap your risky code in a try block. 2. Catch those potential errors with specific except blocks. And 3. Use finally for any cleanup that has to happen, no excuses. Mastering this try, except, finally structure is really the secret to writing professional, solid Python code. So I'll leave you with this question. Think about a project you're working on right now. Where are its fragile points? Where could it break? By putting what we've talked about today into practice, you can build applications that aren't just smarter, but a whole lot stronger. Happy coding.